this problem starts off the same as our other quadratic formula problems, where we make sure it's in standard form, ax squared plus bx plus c equals 0, and it is. So we're going to go ahead and start with the quadratic formula. Our a is 2, our b is 10, and our c is negative 13. So we have our formula, opposite of b, plus or minus the square root of b squared minus 4ac over 2a. You don't need to copy that every time, but that way now it's on your paper so you can use for these next problems as well. All right, so let's take a look. X equals, nice long line, opposite of b. b is 10, this is going to be the opposite of that, negative 10. Plus or minus the square root of, this is b squared minus 4ac. A is 2, c is negative 13, all over 2a. Okay, so notice it's starting off exactly, this is familiar to us. Okay, there's going to be something a little bit different at the end, but we're not quite there yet. Okay, next piece. I'm going to simplify, right? I'm just going to bring down negative 10 plus or minus. I'm going to bring down 2 times 2 is 4. And then here, this I'm going to need 2 steps. 10 squared is 100. And then I'm going to put in my calculator, negative 4 times 2 times negative 13, and I get positive 104. So I'm going to write plus 104. And then when I add those together, this is 100 plus 104, that's 204. Okay, now, what we've learned up until now is that I go and I put 204 in my calculator. It's a decimal, so it's irrational, and we've just stopped here. However, there's more we can do. Okay, so instead of just stopping here, I'm actually going to simplify this radical and then bring it back in, and there's going to be even more simplifying I can do. So I'm going to take this radical up here where I have some space, and I'm going to simplify. Now, when I'm simplifying a big number like this, a great strategy is just to say, okay, what's a number this can be divided by? Well, it's even, and it often will be even, so let's just divide it by 2. And what's 204 divided by 2? Ideally, you can do that in your head, but if you can't, you just do 204 divided by 2, right? That's 102. Remember, even numbers ending in 0, 2, 4, 6, 8, those are even, and they can be divided by 2, always. So look, this number ends in 2, that is an even number. I'm going to divide it by 2. Then 102 divided by 2 is 51. Okay, now this one's a tricky one. 51, what can 51 be divided by? It's not even, it can't be divided by 2. So watch, I'm just going to do like, okay, I wonder if it can be divided by 3. Okay, oh, it can be. So I'm going to say 3 and 17. And 17 is actually prime, right? 17 can't be divided by anything, and I'm done. So I have this as my prime factorization, and I'm going to go ahead and simplify. And what I remember is that when I have those doubles, right, that's 2 times 2 is 4, but the square root of 4, this becomes a 2 on the outside. And this 3 and 17 are singles, and they stay on the inside. And so I'm just going to multiply those back together, and I get 51 on the inside. So this is, we've simplified radicals a lot, and we don't usually get answers like this, but in this case, this is the answer. And so what we do is I'm going to bring it back here. So I'm going to bring down negative 10 plus or minus 2 root 51 over 4. Okay, now here's the thing. This is a fraction. And what we do with fractions is we reduce them to simplest form. So right now, there's actually a number that both the top and the bottom can be divided by. And when I say that, what I mean is I'm looking at this number, and this number, not this number. The reason I'm not looking at this number is this is like, it's inside a radical. Like this number is this. This is the square root of 51. Like I am definitely not looking at that number, right? This is like, we can basically treat this like a 2x. So what I'm kind of thinking about right now is like the greatest common factor. What's the greatest common factor of 10, 2, and 4? And what I notice is all of these can be divided by 2. So what I'm going to do is I'm taking this whole fraction and I'm dividing each piece by 2. So I'm dividing the top by 2 and the bottom by 2. And this is called reducing the fraction, right? This is the same as if I had, like, for example, 4 over 10. I would say, oh, I'm going to divide by 2. I'm going to divide by 2, right? And I would get 2 over 5. This is the same process. So here I'm dividing by 2. So negative 10 divided by 2 is negative 5. 2 divided by 2 is 1. So when I write this plus or minus, I'm not going to write 1 root 51. I'm just going to write it like this. right? That's 1 root 51. And then on the bottom, I'm dividing by 2 as well. 4 divided by 2 is 2. And this is my fully simplified answer, okay? So again, the only difference is when I got to here, I simplified. Look, I brought the simplified version back, okay? And then I reduced all the way. I saw, oh, is there a number that I can divide each of these by? And there was. Sometimes you can't simplify, and sometimes you can't divide, but a lot of the times you can simplify a little bit.